All right, guys. I need the whole period, so let's roll. I just passed it out to you. This is actually 2 sets, 2 sections, 6 sections, 7 notes. But you'll notice that it's more drawings and things like that, so that's why it seems like it's super long, but it's not. And if you notice the board, we're going to do 6, 6 today, 6, 7 tomorrow. We have a quiz Wednesday. I'm rolling.
Can we like? I'm not gonna roll it today.
So Thursday this week, I am not going to see you. I know you would be crushed, but because of the testing schedule, you will not see 1st, 3rd, and 7th period on Thursday.
Oh, dang.
I'm right here.
I like when you give us 1st and 3rd. Oh my god. At least she didn't tell you she hated your hair.
Okay. All right, but you will find this section in tomorrow's. It's actually, we're gonna take a sigh of relief. It's not bad. All right, we're gonna talk about vectors, and there are 7 objectives here, and we're gonna go through each one. But it says underneath number 7, a vector is a quantity that represents 2 quantities, the magnitude and the direction. Examples of quantities that are expressed as vectors are force, velocity, and tension in a wire. So there's a lot of, and you may have seen them if you're in physics. Force is a big one there. So how we represent vectors, at least we're going to do the mathematical side of it. Vectors are represented as directed line segments, and I want you to notice something. You have the initial point, and you have what's called the terminal point, and I want you to notice it's a directed line segment. So there's an arrow here, and that's telling you that it started at P, and it's going in the direction of Q. Now, it's on the paper, but let's kind of maybe write it again so you can see it and practice it. It looks like a double absolute value symbol. It's not, but it represents the length. That's also referred to as magnitude. That's a typo, not magnituded. Magnitude. Magnitude is the length, and we're going to use the distance formula. Okay, you will use, and so you already know that. That isn't anything new, except that that's what we're calling it. We have component form of a vector is, and I want you to also notice these are weird parentheses. They're pointed, okay? So if you have a vector PQ, the initial point is P sub 1, P sub 2. The terminal point is Q sub 1, Q sub 2. Well, component form actually takes it and slides it to the origin, and the way that you do that is you just subtract the terminal minus the initial. And then once you do that, you can call it V sub 1, V sub 2, which is vector V. So look at a practice problem. It says find component form of a vector with an initial point of -4, -4, and a terminal point, that's supposed to be of, 6, 2. So what you do is you take the terminal minus the initial, terminal minus the initial. So 6 minus -4 is 10, and 2 minus -4 is 6. So you're going to just have to get used to the notation. And this is, and oftentimes, like, because you're not going to be able to write a bold V, sometimes we put like a little arrow above it to indicate that it is in fact a vector. All right, magnitude is just the distance. So let's go back up to this component form. If I want to find the magnitude of vector V, you would just do the square root of 10 squared plus 6 squared. That's what? The square root of 136. Well, let's simplify that. Is there anything bigger than 4? Would 16 go in there?
Well, let's figure it out. Nope.
So that's 2 square root 34. Okay, so magnitude is very simple. You're just doing, if you put it in component form, it's just v sub 1 squared plus v sub 2 squared, you take the square root. If you have an initial point and a terminal point, you're going to do the distances. So it's a little easier to put it in component form. If your magnitude is 1, okay, if the length of the vector is 1, that's called a unit vector. All right, so flipping the page. Example 1 says find the component form and magnitude of the vector shown. Well, can you tell which point is the initial point?
2, -1.
2, -1, and the terminal is where the arrow is. So if I want to find the component form, you take terminal minus initial, terminal minus initial. So that's what? -4, 3. Then the magnitude, we're going to call this vector v. So then the magnitude is the length. And it's easier to take the component form. And you should sort of get that that's going to be 5, 3, 4, 5. All right, example 2 is one more, but I didn't draw it. It says find the component form and magnitude of the vector given an initial point of -3, -5, and a terminal point 5, 1. So go ahead and do that. Find both the component form and the magnitude. All right, so for the component form, you should take 5 minus -3, 1 minus -5. So that's what, 8, 6. And the magnitude, what'd you guys get? It worked out nicely, didn't it? 10. Do you get that 6, 8, 10 is a multiple of 3, 4, 5? And you can do that for any triple that way. All right, vector operations. In this section, we're going to look at what's called scalar multiplication. Scalar is just a number. So if I have vector v, I can do 2 times vector v. And all you do is multiply 2 to each first and second component. And then we can add and subtract vectors. And you just add and subtract their like components. So look at example 3. This is really kind of cool and a nice visual. In example 3, it says state the scalar multiplication for a through g if you're given vector v. So vector v is like 2 segments here. Do you see it? Or 2 rows. So in letter A, how would I get this to be half of that? Yeah, or 1/2 vector v. How about B? What have I done to vector V to get vector in B? times vector v. You see that it's doubled? Now, in C, something interesting has happened. It has actually done what in letter C? It flipped direction, right? So guess what that's going to mean? That's negative vector v. And you're going back to vector v every time.
So the arrows are going to be...
Yes, that says it's a vector. All right, letter D. What would I need to do here? Negative 2 times your vector v. Ooh, E's a bit of a challenge, not too bad. Yeah, 1.5, it's 1.5 times, but it's in the same direction. Then what would F be? Negative 1.5v. And how about G? Negative 1/2, and it's okay if you do 0.5. All right, so far so good. Look at example 4 with me, because this stuff's actually very, very straightforward. Not bad at all. Look at example 4 now. It says if you have vector v is 3, negative 2. What would negative 2 times vector v look like? It's going to be negative 6, 4. Do you see what I did? I multiplied each component by negative 2. So you guys, this is really easy, okay? So you guys try B and C.
No, I don't really like to do.
All right, letter B. Did you guys get 18, negative 12? And I'm going to keep returning papers. I have to do stuff while I wait for you. I don't wait. There we go. Okay, how about letter C? If you take negative 1/3, what would that be? Negative 1, well, how about just leave it as the fraction? You're going to take negative 2 times negative 1/3, so it's positive 2/3, right? All right, now flip the page, and vector addition is super simple too, addition and subtraction. So look, if example 5, I have W is negative 3, 4, and V is 3, negative 2. All you're going to do is add like components. So negative 3 plus 3 is 0, 4 plus negative 2 is 2, like that. Okay, super easy. In letter B, you're going to have to do one step before we can subtract. I'm going to multiply W by a 2. That's negative 6/8 minus, and then I'm going to take the V times a 3, so it's 9, negative 6. Just be careful when you do subtraction, because this is negative 6 minus 9, that's negative 15. 8 minus negative 6 becomes 8 plus 6. You get that? That is negative 15, 14. All right, now you guys try letter C. Now be careful that you have the V first, okay? So I got 15 comma negative 16. Are you getting that? Yes? All right, good. All right, unit vectors. The definition of a unit vector U. A unit vector is a vector that has a magnitude of 1 in the same direction as a given vector V. To find a unit vector, you can take vector V, divide by the magnitude. Do you get that? That's going to then divide out the length and make it a length of 1. So look at example 6. This is actually very simple when you do the computation. So example 6 says find the unit vector in the direction of vector V. So the first thing you have to do is you have to find the magnitude, which is the square root of negative 5 squared plus 12 squared. Well, if you know your triples, 5, 12, 13. So you guys right here, this is what's new for you. To find a unit vector that goes in the same direction, the arrow's pointing in the same direction as vector V, you take vector V, okay, this is the formula, and you divide by the length of V. So this is negative 5 comma 12, and we just found the magnitude to be 13. So it's negative 5 over 13, comma 12 over 13. And let me pause here a moment and prove why this is. Okay, this is the formula that it's, if you want to find a unit vector, you take your given vector divided by its magnitude, and let me show you something. If I take this, okay, this is, if I want to do the magnitude of this one, negative 5 over 13 squared plus 12 over 13 squared, that's 25 over 169 plus 144 over 169. Guess what? That's the square root of 1, which is 1. So this formula is forcing it to have a length of 1, which in some instances, that's what you want. All right, two special unit vectors. We have something called I, and it's not the imaginary number, okay? In vectors, I is the component form 1 comma 0, so that's to the right, 1, and it's a unit vector, okay? The magnitude is 1. And if you flip it to the next page, J is another special unit vector. And so before I go on is if I had, say, the vector 3 comma 4, I could in fact say this is 3i plus 4j. And I want you to sort of just watch a moment, because that might be a little confusing at first, but once you get the hang of it, it's like really easy. But at first it's like, what? What you talking about? So watch. If I just told you that the definition of I as a vector is 1 comma 0 and j is 0 comma 1, right? That's the definition. I didn't make that up. That's what it is in vector form. You understand that's 3 comma 0 plus 0 comma 4 when you add it together. So every component form can be rewritten in ij form. Every single one of them. So for example, let's do another one. If I said you have 5 comma negative 2. Okay. Yeah.
Is the J supposed to be 1 comma 0 or 0 comma 1?
Oh, it's supposed to be 0, 1. That's a typo. Thank you. Yeah, that's 0, 1. Yeah, sorry. That's just a typo.
It's okay.
No, I'm glad you asked. Okay, so now if I have, say, 5 comma negative 2, do you understand that that's 5i minus 2j? That's all it is. If you were to put it in I is 1, 0, j is 0, 1, it works out that way every time. So then if I have, let's say, negative 3, negative 8, that's negative 3i minus 8j. And so you might be asking, well, why do you want to do it like that? Well, we're not going to see everything with vectors in pre-calc. I'm just laying a foundation here for just working with them and doing operations. It's in physics, and depending on how far you go in physics, then you have to do some other upper level math stuff to it, that gets into a little bit of calculus with the physics, where you do the I and the J notation. Okay, so it's like very common in physics. Now, it was my understanding that here in physics it's a little bit more conceptual than doing, it's not like a calculus-based physics. Okay, so it says in order to find a vector that's in the same direction as another one, you find the unit vector and then multiply the unit vector by the magnitude of the vector. So, example 7 and 8, these go together. It says find the vector v with the given magnitude and in the same direction as u. So I don't know vector v. That's actually the one that I'm looking for. So what you're going to do is it says find the unit vector. I can find the magnitude of u. So that would be the square root of 2 squared plus 4 squared. That's the square root of what, 20? And that's 4 times 5, so it's 2 square root 5. So, what I know then is my unit vector your unit vector is the, it's vector u over the magnitude of u. So it's 2 comma 4 over 2 square root 5. So that's 2 over 2 square root 5, comma 4 over 2 square root 5. So again, let me read this. You might be going like, what? What's she doing? It says you find the unit vector in the direction of the vector you want to go in. We want to go in the same direction as u. So we're taking u over the magnitude of u, and that's this. Step 2 is multiply the unit vector by the magnitude of v. So then all you're going to do to find v is take 7 times, and we're not going to rationalize here. I mean, you can, but you don't have to. So then my v vector is 7 over radical 5, comma 14 over radical 5. It's a little weird, but true. All right, let's try it again. The exact same type of problem. Example 8 says find the vector v with the given magnitude and same direction as u. So step 1, find the unit vector in the direction of the vector you want to go in. We want to go in the direction of u. So we need the magnitude of u. So that's the square root of 3 squared plus negative 4 squared. 9 plus 16 is 25. The square root of 25 is 5. So you take vector u over the magnitude of u. Now, are you guys okay that 3i minus 4j is component form 3 negative 4 over 5? So that's 3/5, comma, negative 4/5. Step 2, multiply this new unit vector by the magnitude of the given one. So vector v is going to be 10 times 3/5 times negative 4/5. Well, if I multiply by 10, that goes in there 2 times, that's 6, negative 8. So that's the final answer. All right, last page that we're going to do today, direction angles. Theta is called the direction angle and is measured counterclockwise, that's the normal way, from the positive x-axis to b. And what's nice is we learned this before, okay? This actually isn't, it's like similar to the polar information. The tangent of theta is y over x. Or, if you think about it, for v, the A is in the x position and the B is in the y position. So, you're going to use this piece of information that tangent theta is B over A, but you have to put it in the proper quadrant. So if you didn't get this with polar, we're going to get it again. It's going to help us. So tangent theta is going to be 5 over negative 2, and you're going to need a calculator because that's not unit circles. So then theta is inverse tangent negative 5/2. So check your mode, and we'll do this in degrees. I'm getting negative 68.2 degrees. Now, what quadrant should this be in? Because it's not negative 68.2. This is left 2 and up 5. This is where my vector is. Okay, negative 2, 5. That negative 68.2 tells me how far away from the x-axis I am rotating up. So you're going to need to do 180 minus 68.2 to put it in the proper quadrant. So I'm getting 111 degrees, or 111.8. So that's the direction. Magnitude is just the square root of negative 2 squared plus 5 squared. And that's giving me the square root of 29. All right, so let me talk you through that one more time in case I lost you. You know how to do magnitude. Magnitude is the length. So that's just the square root of negative 2 squared plus 5 squared, or square root of 29. I don't think we're having trouble with that. It's the direction angle. The direction angle is tangent theta equals, and this is AI plus BJ. So you're going to take tangent theta equals B over A. So you're going to take inverse tangent negative 5 over 2. The calculator spits out negative 68.2 degrees. When you're doing this, you need to figure out where is the vector. Well, the vector is left 2, up 5. That's like third quadrant. And I'm 68.2 degrees into that second quadrant. So that's where the 111.8 comes from. All right, so that part's a little tricky. All right, last thing. Component form of a vector given theta. This is called CIS form. And it looks like this. And again, you're just going to, it's unpleasant, but you'll have to memorize it. V equals the magnitude of V times cosine theta I plus magnitude of V sine theta J, where theta is the direction angle, and you know that this is the magnitude of V. So look at example 10. It says find the component form if you know the magnitude and the angle. So here's the deal. Vector V, that's called the CIS form, is the magnitude of V times the cosine of theta times I plus the magnitude of V times the sine theta J. That's the formula. Okay, it's right here. This is where that's coming from. So the magnitude is 7. I have the cosine of 60 degrees times I plus 7 sine 60 degrees times J. I think it'll come into focus here when I get to the answer, and you'll be like, oh, that's how they're connected. Well, then here's our unit circle. What is the cosine of 60 degrees? 1/2. And then the sine of 60 is radical 3 over 2. So this is 7/2 I plus 7 radical 3 over 2J. So component form is 7/2, comma 7 radical 3 over 2. That's how you convert. Yeah, I knew it was like once we got to the answer, you'd be like, oh, what are we doing? Why are we doing that? Well, this is a way you can convert. All right, example 11 is a little bit more complicated than that. It says, find the component form of vector V if I know the magnitude of V, but it's in the same direction as W. Well, direction is the angle of rotation, okay? So direction is theta. So what I'm going to have to do is I'm going to have to find theta, and then I can use the CIS form. Well, tangent theta is B over A. So that's tangent theta equals, do you understand I have two vectors here? I've got vector V, and that's the one I want to find the component form of. And then they gave me, really, the component form with IJ of W. But if they're going in the same direction, that's the same angle, then I can use CIS. Well, unfortunately, this is not unit circle, so you're going to need a calculator and press second sine 3 over 4. Check the mode on your calculator, and I got 36.9 degrees. So now I can find vector V. This is 10 times the cosine, 36.9 degrees times I, plus 10 sine 36.9 degrees J. Go ahead and punch 10 times cosine 36.9 into the calculator. And it amazingly came out 8I plus 6J, or 8 comma 6 in the component form, okay? All right, so let me explain what I just passed out to you. We're going to do 6.7 tomorrow, and this worksheet is 6.6 and 6.7. Today, you can do through number 8. Okay, you can get through number 8. So, use your notes, okay? Use the note packet to help you, but again, you can get to number 8, or through 8, including 8. Then tomorrow night, you'll have 9, 10, and 11. Tomorrow's section is super easy. This one had some challenging parts to it, but tomorrow's is super easy, what we're going to learn. And then we'll have a little bit of